Percolate, the kind of technologies that we use, and also the state of the art for our technology. So with that in mind, because everyone can use a little bit of uplifting, particularly today, most of this presentation is tongue-in-cheek. There's a lot of gloom and doom and everything is terrible, which generally it is in front-end development. But please remember that that is all in good fun. So with that in mind, this is arguing with browsers as a career. Front-end development for the uninitiated. Just kidding. The green light's not on. Does that mean something?
Nothing for me. I can see everything fine.
Yeah, that's cool. I'm trying to change slides from all the way over here. Yeah. There we go. All right, second slide. So, as a description that front-end developers are minutes away from jumping, we are going to talk about three things today. We're going to talk about how browsers are terrible because there's so damn many of them. Frameworks are terrible because there's so damn many of them. And tools are terrible because there's not enough of them. All right. So the first thing we're going to do is we're going to have a pop quiz about JavaScript. The first pop quiz is going to be about addition. We're going to add two simple things, 5 and a 3. What do we get? You're wrong. It's 53. We're going to try another one. 5 plus 2 plus 3. What do we think? You're wrong. It's 73. Okay, so browsers. We at Percolate support the evergreen browsers. In the past few years, browsers have moved to a self-updating methodology so that you don't necessarily have to download Internet Explorer 9 or 10 or something like that. It just automatically tells you, hey, there's an update, you should probably restart your browser. Here at Percolate and generally everywhere else that builds websites, they only support those kinds of browsers. So those are the ones we're going to talk about today. What do browsers even do for us? So the first thing that browsers provide for us is a JavaScript environment. For the backend developers, this is your Iron Python or your PyPy or your environment that your code runs in. And the problem here is that every browser has its own specific implementation. These are the implementations for Chrome, Safari, Firefox, and Internet Explorer. I can't remember if that's the right order for them, but V8 is the one that Chrome has built and championed, and a long time ago, they made it a library so that V8 could be separated from the browser and it could be used elsewhere. And that gave us Node, which is the server-side implementation so that we can write JavaScript on the server. So V8 is the thing that powers that. Along with Chrome kind of leading the charge for making their JavaScript engine a module, they also championed speed improvements. When V8 came out, it was drastically faster than everybody else. That was their crankshaft just-in-time compiler. Sorry, this talk might get a little technical for some people. I'm going to try to do high-level stuff. That was their crankshaft compiler. Now they've moved to turbofan and made it even faster. All of these the other three are following suit in speed improvements, and because V8 is all open source, they can take those kind of ideas and move things along like that. So that is the first thing that browsers provide for us, is a JavaScript environment. The second thing they provide is a rendering engine. This might sound like something similar, but it's wildly different, where the JavaScript environment was specifically dealing with running JavaScript and executing it. The rendering engine is dealing with HTML and CSS. And again, every single browser has its own one. The WebKit and Blink, the first two there, those were both used by Chrome at some point. Try to keep track of which one it is now. Gecko and Triton are Firefox and Internet Explorer, respectively. So Triton is an interesting one because Internet Explorer has been the bane of rendering engines for the longest time. But that didn't used to be the case. So Internet Explorer 6 was 2002, maybe something like that. And it was state of the art, the new hotness. That's what everyone built their specs to be. That's what everyone built their site to want to render in. The problem was, back before all of these evergreen browsers came about, that was the only thing that people could use. Nobody updated to Internet Explorer 7 or 8 or 9. And so 6 languished, particularly in customers like ours, enterprise customers, that didn't feel the need or it was too expensive for them to upgrade everyone. Triton became the bane of developers' lives, basically, because that was the lowest common denominator and it was kind of crap, stuck in 2002. So these are rendering engines. They provide something we're going to talk about in the next slide, which is a DOM. For anyone who doesn't know or hasn't met, this is our DOM here at Percolate. So that's the rendering engine provides the DOM. There are two other things that are interesting, a window dot and a document dot. The window and document are two ways that JavaScript interacts with the rendering engine. So we're going to talk about window specifically, window first. Window is a global namespace. So in something like Python, most of the developers here are Python developers. You don't have a global namespace, you have modules, and you export things and you import them based on modules. You don't have things floating around in global namespace. PHP is a little different. PHP is the other way, where things default to being in global namespace. Well, in JavaScript, things default to being in the global namespace, and in the browser specifically, anything in the global namespace is attached to window. So the way that you used to use libraries, such as jQuery that we're going to talk about later, is you would just include the library and magically jQuery would appear on the window. You didn't have to do anything, you didn't have to include anything, and that's how libraries used to work for the most part. We're going to talk about why that isn't the case anymore and why that was a really terrible idea. So the DOM is what we're going to talk about for most of the rest of the presentation. The DOM stands for Document Object Model, and it has to do with this document dot, a global that is given to us. Yep, you can use window.document because it's a global. So the document object model is the way that the JavaScript can operate on the rendering engine, the things that the rendering engine does. You can add nodes, you can remove nodes, you can change styles and CSS all through this document dot property, and that's all part of the DOM. Now, that's a fantastic thing. Suddenly we have access to all of the visual aspects programmatically through JavaScript. The problem is the DOM is really, really, really slow. Anytime you want to touch styles or adding or removing things or changing sizes, the browser has to do a whole bunch of computations for painting. There is a particular step in the browser rendering loop that happens that is paint, where it literally paints the pixels onto the page. And that's a particularly slow calculation that has to happen. So modern frameworks that we're going to talk about later have found ways to improve this and get around it, but that's just something to keep in mind that we're going to talk about later. So the last thing that they provide is a window. Yeah, sure, let's do it right away. So the question, right. So the question is, if document dot is a tree, why is it slow to manipulate things, right? The first part is document dot isn't a tree. You have to query things. We're going to talk about that a little bit later on in our why things are slow part. We're gonna cover all that and why it's slow, why it's not potentially anymore, and ways we get around that in the interim. But the biggest thing to take away is document isn't just a tree. You can't do document.div.div.style. That's doesn't work that way. And it would be just as slow if it did, and we're going to talk about why later. Cool. So, another pop quiz. We're going to talk about truthiness. 0 is greater than null. False. Ah, crap. So, 0 is greater than equal to null. Ha-ha. So that must mean 0 double equal to true, or double equal to null. False. Ah, somebody's been paying attention. Okay, so now we're going to talk about frameworks. The first thing that we're going to talk about is jQuery. Now, the reason jQuery came about was because, as we mentioned earlier, browsers have a whole host of their own implementations of basically everything. A JavaScript environment, a rendering engine, all of that stuff. And what jQuery wanted to solve was how to access and manipulate and do all of those things in a single unified API. jQuery was very much not the first framework to allow this or to accomplish this or even to attempt it. It just gained the vast popularity. That number 80% there is the market share today, 10 years after it's been released, 10-ish years after it's been released, of the top 1 million websites that use jQuery. We use jQuery. It's mostly a legacy thing at this point. A lot of modern tools and libraries don't depend on jQuery, and we're going to talk about why later. But when jQuery came around, it was a fantastically easy thing to use and do and accomplish all of the things that you were doing by hand and having to do in different browsers, all with one singular API. So this first thing that we have here, $function, that was a way of booting itself. So when a browser loads, we talked a little bit about its cycle. It has a paint cycle. So the first thing that happens is all of the HTML gets loaded and parsed, and then the CSS gets loaded and parsed. The problem is the JavaScript, if you have it in a certain place, also gets loaded and parsed before everything gets painted. So the problem there means that if you try to manipulate, say if you try to remove a node or change a style on a node, before the browser has actually rendered it, you get an error because it doesn't exist. And so what this $function booting sequence basically prevented all that. It waited until the browser said, hey, I'm done, I'm rendered, you can now, things are in the DOM, you can now touch them and manipulate them. So that was one of the first not innovations, but one of the first helper things that jQuery provided. The second one is $string. And so earlier, to answer your question, earlier the way that you would have to talk to or manipulate a DOM node was to do a document dot and then a query. It was query selector or get element by ID or get element by class. And those methods all changed depending on what browser you were using. So this $string made it easy to select a DOM node across browsers. You didn't have to know which function to use. You didn't have to use a different function depending on if you wanted to select by class or ID. It was a single, easy, unifying way to select a DOM node anywhere in the DOM tree. It was extremely powerful and still is extremely powerful. And we're going to see later that browsers have implemented a standardized way to do something similar to this with query selector all. So that we can select things, arbitrary things in the DOM node with one singular API function call. The last major thing that we're going to talk about today, there were a bunch of other major things that we're not going to talk about, but the last major thing is .ajax. So this provided a way to talk to external things, make AJAX calls. This was a huge proponent of when this was coming out, Web 2.0. Everything was AJAX-y. You didn't want page loads. Everything was smooth and silky, and it slid in as you did things. AJAX was the workhorse to make all of that happen. It had a unified way of talking to external servers using all of the different browsers implementations of XHR, which was the built-in browser API to talk to external servers. But thanks to jQuery, all we had to do was .ajax. There were some help methods for .get, .post, that kind of stuff. Made it super easy to talk to external servers. So these are the big three things that jQuery and other frameworks provided. So now let's look at a standard example. We're going to look at this example in 3 different stages of frameworks. This is a simple way of clicking on a little link or a little text. And when you click on it, it changes the text inside of it, that closed text, between opened and closed. And this example here is in jQuery. So we can see, we're not going to talk about this too much. It's meant to be just an example of the amount of code that needs to happen to accomplish this. You can see our $string and then a callback of some event that happens. The biggest thing here is the kind of jumping through hoops to get and set and context here. You'll notice there's a this, and then you have to $sign this, and what does that even do? So there's a lot of built-in knowledge here for what has to go on behind the scenes to make sure that you're selecting the right thing and changing the text at the right time. The biggest thing to take away here is the lack of lines of code to accomplish something simple. If you want to change the text on this, it's 3 lines to react to a click event and toggle the open and close text. And that's it. Super simple. This was the kind of coding that was very, very prevalent until 3 or 4 years ago, until other frameworks came around. The problem is you would have these kinds of things everywhere in your code. It's very easy to stick this in any file because it's in global namespace. That $sign there is in global namespace. It's very easy to attach this anywhere, stick it in any file, get it lost. So the 2 main things that other frameworks worked to solve was context and code clarity. And we're going to talk about that with our next framework that we talk about. And the next framework that we talk about isn't actually a particular framework, it's a class of frameworks. So round about 2010 maybe, even a little bit before that, front-end developers looked around and saw that all of these back-end developers were using this fancy technology called Model View Controller. And for non-technical people, what that means is that there's a particular way of the actions, that way that actions flow through your code. And it's really unimportant how it works, but all we care about is that the front-end developers looked at MVC frameworks on the back end and said, hey, we can do that. That would be great for single-page apps. So round about this time, when these are the 3 largest of these MVC single-page app frameworks came around, Backbone, Ember, and Angular. Right about that time, Web 2.0 was in full swing. People wanted to have everything on the client side. This was also coinciding with Chrome being released and pushing the envelope as far as JavaScript speed. So things were actually performant in the client side. So people said, you know what? We've got Ajax. We've got some frameworks that we can use. We don't need to have a page load every time we want to do something. So that's what people turn to with these frameworks. The problem is we hadn't really figured out yet that the reason server rendered HTML and regular apps up until that point were fantastic was that you could see things immediately. You land on a page and bam, everything's there. You don't have to wait for things to load. And so what happened was Twitter moved to a single page app in 2009, maybe 2010. and there was a huge uproar because what happened was when you landed on twitter.com and tried to load your timeline, you saw a white page. And then suddenly, bam, there's a whole bunch of stuff that's there. And so if you are on a mobile phone, or if you are on a slower connection, say somewhere that isn't in the first world, that's going to be really slow because it has to first talk to the server that tells it to load a bunch of JavaScript. And then that JavaScript has to go back to the server to load a bunch of other stuff that it then has to render. So it added a couple more round trips, and it didn't really work great. There was a lot of uproar, and they ended up going back to a different kind of rendering. And a lot of early adopters of this technology suffered the same fate. They had a lot of pushback from customers that they didn't like, that it felt very slow. Things have since improved. We use this kind of 2 round trip at Percolate. We have a very light page that first loads, and then we boot up some JavaScript, and that JavaScript goes and fetches some data, and then we render some more data. We're going to talk about that after Backbone and Ember and how that gets accomplished. But the takeaway from all of this experience was that it broke more things than it solved. This hash index came about because we hadn't figured out how to do URLs prettily yet. When you landed on a page, you usually landed on twitter.com/whatever. The problem with this single page app was that they wanted to maintain history without changing your browser. So instead of being able to do that the way that we do now, the way that we figured out now is with slashes and looks like a normal URL, they had to do that after the hash. Browsers treat things after the hash differently. It doesn't reload the page. I don't really want to get into that, but that's the way that things had to work with these frameworks early on. Things, like I said, things have changed since then. The other thing is that mobile performance at this time was absolute crap. Phones were very slow, networks were very slow, and so both of those things combined meant it was a very, very terrible experience. So you either had to live with that terrible experience or have a completely different rendering path on the server so that you sent a whole different code to the browser. So you either had to maintain 2 code bases or live with slow performance. So that's good and all. You've decided that you want to use, say Backbone was our legacy framework that we use here at Percolate. Say you want to use Backbone and you want to do a single page app. Well, now you have to figure out some way to translate your data that you have that you fetched from the server into HTML that the browser understands so that you can add them to the DOM. Because what you don't want to do is render things on the server side and just send that blindly to the client, because then you're just rendering in server anyway. You want to render things in the client. And so the way that that is done is with templates. Mustache and Handlebars are 2 of the larger libraries that do that. It works like any other template. There's variables that you can replace. The drawback to all of this is that it's not very performant. JavaScript, specifically at this time, was still very slow, as we talked about earlier, and so having to interpolate strings, potentially huge strings, because your entire app, all of your HTML was in the client side, having to interpolate all of those strings and replace all of those variables was not very fast. So all of these things put together give us this. This is the exact same behavior and HTML as our first example with jQuery, with a lot more code. We're not going to talk about the specific implementation. Again, this is just to show you the sheer volume of code needed to accomplish. This is in Backbone. You've got a couple things going on here. You've got up at the very top, it starts with a function, and then way down at the bottom, it calls it automatically with a jQuery parameter. That has to do with context and making sure that things don't leak globally. That solves one of our problems that we talked about earlier. This was one of the patterns adopted with this generation of frameworks, was to be a good citizen and not leak things to the global namespace. We've also got a dependency on jQuery here. So we've only slightly improved ourselves. We've gone from using just jQuery to using another library on top of jQuery. But it functions exactly the same way. When you click, there's a click handler function. But now instead of actually replacing or testing if the text is open or closed to replace it, we now test some state. So Backbone is a stateful framework. It allows you to change things very, very quickly because JavaScript is much faster than touching the DOM. So instead of going and looking things at the DOM to make decisions, we just look locally in memory in our state here. So this is a same implementation in Backbone. State, correct, yeah. It's exactly analogous to a long-running server that has state for anything else. It's just a variable that's stored on the actual instance. So now that we've moaned and poo-hooed about Backbone and Ember and the other one, let's talk about types. Our next pop quiz is all about types. So this is an object. We're going to ask the type of object is going to be object. Wonderful. The next one we're going to look at is an array. This is actually a square bracket and a square bracket. This font is terrible. And that is also an object. So now that we've talked about our grandfather's frameworks and the old and busted way of doing things, we're going to talk about the new hotness of React. React was something that was written internally by Facebook a few years ago and released open source in 2014-ish. So previously and up until this point, we've been talking about the DOM as this big, huge, kludgy, slow thing that we need to touch anytime we want to update the browser. Well, recently, JavaScript performance has been improving and improving. So what a lot of people have decided to move to in React specifically is a thing called virtual DOM. And so virtual DOM gives us the ability to represent a tree-like structure in JavaScript so that we don't have to go and touch the browser's version of the DOM every time we want to update. So that allows us to be extremely smart about touching the real DOM. We can build diffing algorithms to determine the new DOM versus the old DOM and then touch just one tiny little thing as opposed to re-rendering the entire tree like we do in Backbone. We didn't touch on that, but that was one of the main things that React in particular. There are some other competing libraries that do similar things that have this virtual DOM that they use. And so here are the reasons that React has gained so much momentum and a lot of people are really enjoying using it now, is all of the things that we talked about. JavaScript is fast for some definition of fast, or at least much faster than touching the DOM. And that allows us to store things in memory in the browser and use our diffing algorithms to only touch as little of the DOM as we want to. The problem is that when we talked about the previous generation of frameworks, there was a white page of doom when you first landed on the page of Twitter experienced this, and to some extent, Percolate experienced this as well. There is a solution to this. We don't use this at Percolate, but it's something that we can potentially use, and it's isometry. So React is isometric, which means that it can run in the browser, but it can also run on the server in Node. So that means that we can render things in React on the server and then spit that rendered HTML out to the client immediately. So we don't have to render things in the browser and wait for things and have this white page before everything loads. We can do that all on the server and then spit out that to the client side. The magic part of this comes in When React then boots on the client side, we can immediately interact with it. It doesn't have to re-render anything. Everything is already responsive. That is not very widely used because you have to, you're tied to using Node on the back end. At Percolate, we don't use Node. But that's certainly an option if a particular developer or company or something is interested. It's a way around having that, the perceived lag in rendering time. That's correct. It's just to save the initial rendering time. Everything after that is done in the client, any additional rendering. And so this is our click me example done in React. There are two things to pay attention to here. When React came about, they decided that they didn't want to do the same mistakes that Backbone and that generation of frameworks had come across. Namely, they didn't want to use strings and templates for building all of their HTML, all their client-side rendering. So they came up with this now markup language called JSX. And you can notice here, there are div tags and a component tag in the JavaScript. The answer is browsers don't understand this, but we're going to talk about that in a little bit. But what this allows us to do is this allows us to write HTML in our JavaScript and cry into our pillows at night. And React interprets a version of this and understands that we want to render things. So we still have state, this.state.open, but it's significantly less amount of lines of code than we saw in Backbone. Still more than jQuery, but we don't depend on jQuery. React is completely independent, has its own methods of touching the DOM, doesn't depend on jQuery to do that for it. So that's the first thing to notice here. The second thing to notice here is that this doesn't look like normal JavaScript. We're declaring functions here, but there's no function keyword. We've got a module.exports down here at the bottom. What the heck does that all mean? That is a newer version of JavaScript that we're going to talk about in another couple slides. And React is made to interoperate with older versions of JavaScript and newer versions of JavaScript. So it supports both ways of doing that. Yeah. Correct. So React is extremely flexible with how you want to do presentation and logic and things like that. React itself is strictly Vue. It and obviously does support logic in the Vue, but there are, this is part of a bigger thing called Flux, and Flux is just a philosophy of how data travels and the direction of data in the client through the frameworks. And this is just a very plain implementation of it, but if you wanted to get completely proper with separating your logic and your view, you would move these to an action in a store. So instead of using an MVC, you've got this presentation and actions and stores, which accomplish the same things. This, again, is just a very simplistic way of doing things. Backbone had something almost similar, and that generation had something almost similar, but most of the logic was still contained in either controllers or models. So the previous generation separated that much more cleanly. Okay, so I'm pretty sure final quiz, we're gonna add other things to other things. So we're gonna try now a array plus an array.
It's like a string. I knew this one. It's a string. Yeah.
Yeah.
Crazy language. This is like a language for like 1,000 infinite monkeys. They'll hit something eventually.
Yeah, pretty much. And I'm pretty sure Philip is cheating and looking up answers on his laptop.
I actually wrote about this once a couple of companies ago when we did Node, and JavaScript horrified me.
Well, there you go. So now we're going to try to add an object and an array. That gives us 0. Now we want to add an object in an object. If we got a number before, we're going to get not a number now. All right. So we've talked about frameworks and we've talked about browsers. Now we're going to talk about the tools that developers use to get the ideas from code to processing to the browser so that users can use them. Here at Percolate, this is what our stack generally looks like. Code flows from brain to editor to grunt, which is a task runner, very similar to rake in the Ruby world or make in, I don't know, I think my grandfather used make. And then grunt runs webpack. Webpack is a library that allows us to write node-like code. It allows us to use the module.exports that we saw in the React example. And it translates all of that so that we can use that methodology in the browser, because browsers don't support that kind of JavaScript code and files and separate modules for everything. Webpack allows us to do that. Babel is the transpiler that we use for translating newer versions of JavaScript and JSX into JavaScript that browsers can interpret. We're going to talk about the newer versions of JavaScript in a little bit, but that is the tool that allows us to do that, Babel. There's a little bit of magic that happens. Specifically for larger code bases, there's some chunking that happens. There's dependency management so that we can use different modules and just include them. And then we uglify, which means we shrink things down, make them as small as possible, and munge them so that the files that we deliver to the browser are as small as possible. The next couple of slides, we're going to talk about. Yep. Mm-hmm. Yeah, so the question was the translation from JSX to regular JavaScript happens specifically in Babel. That's where that happens. Correct, yes. There is no way to use JSX natively in the browser. There are various standards that are coming up for template tags, but again, it doesn't interoperate with React specifically because React supports stateful and on event. Mm-hmm. So the just-in-time is specifically for just the runtime environment. The way that works basically is it's a efficient, basically machine code compiler. So similar to the way that the JVM has a it's built into the browser. It's not something that we control or deal with anything. Mm-hmm. Yeah. So now we're going to talk about that magic step a little bit. So we'll talk about Python. Python, when you point it at a main.py, at the very top of it, you can have things that you include. So you use import something from something else. In Python, the environment, the language, knows how to go and fetch that thing from a file and import it and do things with that. Browsers don't know how to do that at all, but Node does. On the server side, you can do something exactly like that. It's a little bit different syntax, but knows how to go and fetch a file and then use the things in that file. Browsers have no idea how to do that. So what we have to do is we have to compile all of those things together, send them as one file, and then each one of those gets wrapped inside of a function. So we're going to start with the very top 3 lines of code there. We want to export a single function that just logs hello. in our compilation step, we end up with these 7 lines of code where our original code here is wrapped inside of a function that's part of an object. And then down here, we see other numbers. This is a super, super high level way of saying that our tools allow us to write code like we would on the server and then deliver that to the browser. This slide right here is an entire presentation itself. I'm drastically simplifying and glossing over just about everything that's hard about this. But I just wanted to give you an example of the kind of stages that it goes to from what we look at and what we write to what the browser sees and executes. I will not be fielding any questions about this slide. So everything that we've talked about up to this point, we've compared kind of the old way of doing things to the new way of doing things. The old way is sort of a hipster way, where you would just wildly throw some jQuery on there and you hand coded everything and exactly what you wrote went to the browser and everything was very simple to reason about. And nowadays, after all of this tooling and newer ways of writing and newer methodologies have come about, what we write and what the browser sees is drastically different. There's almost no correlation. The way that we have to deal that I forgot to put in here is a thing called source maps. So source maps allow us to tell the browser and say, hey, this file that you got that is 1 line and 3 million characters long, this little bit here in the line corresponds to a unminified, unmunged version that looks like the code that I'm writing. And so that's what source map does. Source maps allow us to say this file looks like this in another state, in another lifetime, basically. And so that's the before. Why do we need that? Because it would be literally impossible to debug anything without source maps, because it would say undefined is not a function at line 1, character 45,000, which means nothing to us. It doesn't translate to anything that we're seeing in our editor. All right, so now let's talk about the future of things to come. We've talked about the frameworks that were Christmas past, the React that is Christmas present, and now Christmas future. Yeah, question. Future. That's future. Yes. Yep. Thanks for getting that joke. So all of the things that most of the things that Babel solves for us is translating code that we want to write into code that the browsers can understand. And this slide just lists some things that are different between what was called at one point ES6 and is now called ES 2015, because there's a 2016 and a 2017 and shoot me in the face. And these are just some things that are different that Babel transpiles for us. New syntactic sugar on top of functions, new ways of declaring variables with constants and let. Classes are now a thing in JavaScript that weren't before. Everyone's mind just got blown. And exporting things with modules. Again, this slide is not meant to be exhaustive, and I won't be fielding questions on this slide. The reason that we still have to use Babel is because of this image right here. This is the browser support for ES 2015 features. As you can see, most of the things that we use and know and love support most of them. Chrome has 97%, Firefox has 90-ish%. And then over here, eating some paint, is Internet Explorer 11. Which has a surprisingly large user base still. But all of that put together means that we just can't ship the code that we write to browsers. We have to transpile it somehow. So this slide we've seen before. These were the three of the things that jQuery provided for us. And in ES15, we don't really need it anymore because browsers provide a standard way, a standardized API of accomplishing the same things. We have a document on load that existed, has been around for a long time. It was just kind of a pain in the ass to use, still is, but we don't specifically need jQuery just to accomplish this. One of the larger things is this document query selector all. We talked about using a string to select DOM nodes. Browsers have standardized a way to do that now with this API that's available in just about every browser that we support. The problem child is Ajax. This is the code to go and fetch things and log a response from an external server. There's still no easy way and standardized way to do this. So for the time being, we still generally use libraries to accomplish this. There is an emerging spec that nobody has really standardized on yet, but it's not on the slide because it's kind of crap anyway. So that is my presentation on the state of the art of JavaScript. It's mostly terrible, and I want to tear out my hair almost every day, but I absolutely love it. And so people don't think it be like it is, but it do.
Great, Andre. Thanks a lot.
Any lingering questions? Was that you, Philip?
Yeah, I do have one question, I guess. It sounds like, you know, if you're using Babel to translate between all these things, and even if not, that anything you do, it simply has to be convertible to anything else. Or is that a problem in practice, that you can somehow write something that won't be convertible, or no, that's just not possible?
Yeah, so you get into a state, the question generally what I think is, can you write things that Babel can't understand or understands wrong and now puts something that is incorrect or browsers can't understand?
Yeah.
The answer to that is very yes. You get yourself into a state where you're dependent on this third-party thing to translate your code, and there might be bugs in that third-party thing.
Right.
There was a very well-known bug for a while where using a specific kind of loop, a for of loop, which is ES15, syntactic sugar, Babel translated it in such a way that Safari couldn't run it. It threw an error, it blew up, it choked on that kind of thing. So yes, you are at the mercy of this third-party tool to translate your code. And it has caused problems in the past. There are bugs in everything. So yes. The question is, why is everything terrible? And the answer is yes. It has a lot to do with, yes, browsers are competing. In the case of Python, or generally any language that you would run on a server, you have a choice of what environment you want to run in, right? And you can choose what features you want to use based on what environment you run in. Python, there's a whole bunch of different interpreters. Ruby's the same way. You can control what environment your code runs in. Browsers don't do that. You can't control the environment. You can't control what features it supports. And you just don't have any choice. The users are the ones that have the choice. So it's very much akin to before interpreted languages were a thing or VMs were a thing. So before Java came along and it's write once, run everywhere, you had to compile for different architectures. It's a very similar kind of state of affairs where users are choosing to use different browsers, which would be akin to different architectures or platforms. And so you have to write your code in such a way or deliver your code in such a way so that it can run on any of those things. Correct, yeah, you have to do it at runtime. that doesn't really answer the question, though. That doesn't answer the question of why everything is terrible. The other reason is because everything is done by committee. It's decisions by committee. And it was 9 years, I think, between ES5 and ES6 that those changes got approved. There were literally other languages that popped up as supersets of JavaScript, CoffeeScript, TypeScript, to kind of alleviate the pressures of things that ES5 version of JavaScript didn't support. But you were in the same boat at that time. You had to transpile something to something else to be able to run it in the browser. So I would like to place the blame on standards bodies. They can't move fast enough because JavaScript is moving so fast. Node, the server-side implementation, is the perfect example of that, right? It's only one environment. It's the only thing that people run JavaScript on the server. And so anything that it supports, you can use. That's just not the case in browsers. Anybody else? Yeah, Unique. Yeah, so the answer is React a big enough hammer to use everywhere? No, absolutely not. If you are just doing a small little thing, use the right tool for the right job. Unfortunately, that's not the answer everyone wants to hear. Nowadays, the very first thing people do is reach for React. Are you writing something in the browser? Do you need to display something? We're going to use React. It's a slightly sad state of affairs that just about everything is moving to a single page app. I personally don't agree with that. I think that it should be a very light touch for those kinds of things. And at my previous job, I actually built something so that React and server-side rendering things not in React could interoperate. I sure hope I'm using that word correct because I'm using it a lot. But again, use the right tool for the right job. If you know Backbone or know Angular super well, use that. Don't bother with React. Yeah, if all you need jQuery for is going and fetching things, there's other better libraries to just go and fetch things now. One of the other things I didn't talk about was promises, which is asynchronous kind of stuff. That's a whole nother presentation that we could go into. Promises versus async await, which will sound familiar to Python guys.
Promises are actually kind of cool.
Promises are very cool.
Except they only exist to solve a terrible problem. So it's like,
Yeah, and they're also not standardized yet. So, okay, that's it. I'm exhausted. I'm done. Thanks, guys.
Great. Thank you, Andre.
I feel like that's a dig at me. Oh, no, why? No, I'm just kidding. I'm just kidding. What do you mean by table? That's the same answer as unique is use the right tool for the right job. We're definitely